Hi, and welcome back to CMG-MathSpace. Gradually, we are stepping boldly into the math space, so stay tuned. Now, this episode is entitled The Concepts of Venn Diagram Representations, a simple guide to set union, intersection, and complement. Before we start shading regions in Venn diagrams like A union B and A intersection B or A complement, it is important to understand what those ideas actually mean. So in this video, we are not going straight into drawing or shading. Instead, I want us to take a step back and understand the concepts behind these notations, what union means, what intersection means, and how they relate logically to sets. So you already know what we have been doing on this channel. Our idea, our main focus or objection is to make you understand the concept before the practice. That is our main focus, our objective on this channel. So if you are new here, please like, subscribe, and share, and then you stay tuned. Now, we are going to break it down step by step so we can all understand the logic behind what we will talk later, right, about drawing. Once we grasp that, the shading becomes much easier and more meaningful. So there are some steps that we need to follow, key steps that we need to follow. So the first one is to make sure, don't assume. I said math is not abstract, it is practical. So make sure first thing on the line, or first thing to do actually, is to draw your rectangular box, right? I'll be going back to, let's say, the Venn diagram. So I think I'll share an image in the comments. You can download and be using this as a guide. So this is 2 sets. We will be escalating into 3 set problems. So just stay tuned. So the first thing is to draw your rectangle. The 2 overlapping circles labeled A on the left and B on the right. Then mark 3 regions. I mean the left only, the middle overlap, the right only. So optionally, you can label outside region as neither. You understand? So you pass the expression. Read it out loud. If there are parentheses, handle them first, right? So once again, we have the box. You see the more like a gray or blue region. That's the universal set. We have the A, the whole of A, and then the whole of B, and then we have an intersection area, right? And then A union B means it can be read as A or B. That's mathematically, right? Intersection is where we talk about and, right? So that is it. So get the rectangle, you get the regions, you label them, right? Now the third item is to translate each operator into the region description. So we have A union B, which is left only or middle or right only, right? So basically or literally what we mean is that you shade all the regions within A and B, and that will affect the intersection. Right, now we have A intersection B, and this one talks about only where there's the overlap, right? The overlap, right? The middle there. You see that color portion is a bit deeper, more like a mustard color. So that's what we're talking about. I can't be swapping them going left and right, so just have the image alongside, and then be checking that, right? So now we have A complement, the A apostrophe there. That means everything except the entire A circle, right? So that is outside A. So we shade everything outside A, right? Everything outside A. When you say A, that means the intersection part of A is also part of it. So everything outside A. There's a difference between A only and then A complement. So get that right. We will talk about that A only later. So that is it. But for the complement, it means everything in A, including the intersection part. If it is B complement, it's the same idea. Now we have another thing called A stroke B. That sets a difference. That is left only. So if you are saying left only, it means that the A portion, right? That's what I'm talking about, the A portion, but not B. So you shade only. Let me go back. So if we see A here, so the portion which seems a bit deeper is not part. So that will mean only A, right? So we shade only the A aspect, and not including the intersection. That is the difference between the complement and the only aspect. So that is it. Now the fourth point, if you are talking about use complement carefully. Why is it? A complement means shade the outside area, right? A complement shade outside the outside area. So that is it. Now if expression is into A intersection B, what does it mean? Shade everything except the overlap. Shade everything except the overlap when we have something like into bracket, right? So that is it. Now we have 5. If expression has intersections of complement, apply the De Morgan when helpful, right? So the De Morgan rule is we have these two rules. It's as simple. So we have into A union B all complement, which can be expressed again as A complement and then intersection B complement, right? So which means you shade what? Which means what? Outside both. Outside both. This may still seem abstract, but in practice, we'll be showing you the circles, the areas of the regions of the what? The Venn diagram. So don't worry. Now the second formula is what? Into A intersection B or complement, which is also expressed as A complement union B complement, right? Same as what? Everything except the overlap. So we'll show you diagrams later. So the reason why I'm doing this is that when I am teaching, because I'm limited on TikTok time, video recording or upload, I have only 10 minutes for a particular video or a session. So I don't want to be coming to this expression, be talking about them whilst I do the demonstration. So this thing should be at the back of your mind, not actually chew and pour, but you should have a fair idea of what these things mean, right? Now we have practical examples. For instance, we have shade A union B. What does this mean? So what it means is that read A union B. We are taking the practical or the literal meaning. Now, any element in A or B, I told you if you see anything like A union B or C union without any complements, no circles, just go straight to them and then be shading them with the idea of the properties of what? The sets, intersection, union, and complement. Just go and do that. Simple. There are no restrictions around it. The difficulty comes in, or what can I say? It comes in when there's complement, there's brackets, parentheses, and all that. That's where we have a bit of difficulty. So that's our main aim, to let you understand. Now the second is regions, right? So the regions, now we have left only, overlap, right only. So what are we saying? What are we doing? Shade all 3. Everything inside either circle. That's A union B. So the circles A and B, you shade them. Now bear in mind, the moment you start shading them, default or automatically the intersection will be shaded because they are union. Union means addition of everything in these two sets. That is including the intersection. Now example, shade A intersection B. So here what it means is that we are only looking at the intersection. Don't shade anything apart from the intersection. So we are shading the intersection only. That's the overlapping area. Now, example 3, shade A complement. What does it mean? A complement means that everything not in A. Right? Everything not in A. So the area, that means we are going to leave the area of A complement. Now, A complement includes the A only aspect and then the intersection. So these are the two areas that we are leaving. Now, outside the area of this particular circle A, we are shading everything. That is what it means. That's A complement. But if you are saying A only, that means you shade only the A aspect, not including the intersection. Get that right. Now, 2, shade the region outside the circle. This includes the right only, you understand, if B is not the right and not in A, right? And then the outside of both circles, blah blah blah. That's what I've explained earlier. Now example 4, we shared A set difference of B, right? So that means A minus B. What do? Read. So elements in A but not in B, right? So that is it. The whole of what? Elements in, okay, you are saying that that's left only region. The left only region, like I said, left only region. We are saying A minus B. So the left only region, that's the A aspect, the only aspect of A. So now I think I don't have to be going back and be explaining only A only in complement. You know what you mean. I've explained from the onset. So that is the idea. Don't worry. We do them practically where I show you diagrams and with the shading and everything. Right. Now example 5. Shade into A union B. What do? You compute A union B. Everything inside these circles. We have told you what the union means. Everything in A, everything in B, and then the intersection automatically will be shaded. Now, the complement, everything outside both circles, right? Everything outside both circles, complement, right? Now, shade outside both circles only. So we are shading only the outside both circles only, right? That will include leaving the only A aspect only, the intersection, and then B only. We are leaving this and then shading outside these areas, these regions. Now, example 6, shade A intersection into B complement. Now, there's a rule that you have to be cautious of. Whenever you are doing this shading or this computation, make sure you deal with the one in bracket first, then you move towards the union. From union, you move to intersection, then from intersection, you move to complement. But whenever there's complements in every expression, make sure you do the complement first. I hope you understand. So, parenthesis, union, intersection, and complement, right? But whenever a complement is combined to a group, is attached to a group, you deal with that first. Then you go in depth, right? So here you see into B complement. So what do? You have to do B first, the B complement first. Then you start moving outside. So everything not in B. Now A intersection B complement. Parts of A that are not in B. So the left only region. You understand? Now we have 3 set examples. We have dealt with the 2. So if you really grasp the 2 set notations or 2 example illustrations, then dealing with the 3 will not be that difficult. It's the same idea that we are escalating or moving, transferring into the 3 sets problems or the 3 sets, right? So label the regions. You automatically have, if you label them right, you have 7 regions, right? The first one was like about 4. So having 3 circles, you add 3 regions addition, right? With the 2 sets, we were having about 1, 2, 3, 4, I think 5. So yes, you have 7 for the 3 sets. Now let's look at the method, right? So step method, past expression mean read them out like in English form, right? The natural language that we know. Now let's switch of the 7 regions satisfy it. So you are reading them literally or verbatim. Shade those regions. Example, A into B union C. That will give us an expression as A intersection B or A intersection C. I know you know this expression, right? So you shade these regions 4, 6, and 7. If you don't label them well, that will be your problem. But the naming of the regions depends on you. If only you really grasp these concepts, the number it doesn't have to be the same as mine. But at the end of the calculation, you have the same answer, because we are shading the regions and not really the numbers, right? So that is it. Now all parts of 7 that overlap C or B or C, you understand? Now then the De Morgan rules, like what you were saying, we can use them as a tool or a guide or as a formula, right? Why are they useful? They are useful because they help us to convert complements of big groups into intersections or unions of what complements. So we are just simplifying the shading to be simple, to be easily understood or easily what solved, right? So now there are some common mistakes that we make because of the difficulty in understanding or shading these areas. Let's look at these common mistakes that you can desist from. We have mistaken complement for empty region. You realize I drew your attention on this. Complement is not the same as empty regions, right? So students will think complement is equal to blank or space inside the U. No. So clarify it's that everything that you have named, right? So clarify it's everything outside what the name set. Just make sure you have what determine that. Then the second thing is what shading intermediate steps as final. What does this mean? Normally, the moment we see the question, we don't relax and then understand, let's say, the board math aspect of it, right? So aspect of it, I told you, when you are given that, you have to check the bracket, the complement, the union, the intersection, solving them in that way, in that precedence, else you get it wrong. So that's why we are saying that we rush in solving this. And some of us, to the moment we see it, we panic because they seem too cumbersome or obscured. No, just relax. Now, so the third one is forgetting region exists. There are some regions that we have, like the U. The U is what is very important because most of the work or the shading is where you be shading, right? But we forget that that's also a region, right? I introduced you to that in the chart, right? In the Venn diagram, the U, the rectangular box, inside the rectangular box. Yes, that is it. Now, mixing up union intersection, right? You mix them. You don't even know or understand the difference between the union and the intersection, right? And when you see all means union. And union means addition of the content of the various sets regarded or under discussion. That's union or addition. We are joining them. Intersection is where you have the word or English word as and, where a particular point that certain elements meet only. Then applying complement only to circles, not grouped expressions. So we have this like the group in this in the bracket. I told you in the bracket you consider that, and then when they are not in bracket, and sometimes when some are in bracket, you can actually group them with your ability to solve these things with the proper lesson that we are going to give. If you are able to understand the concept, you will be able to. We have that flexibility around all these questions. They will be very, very, very simple for you. So thank you very much for watching. We will see you in the next video where we will tackle the various Venn diagram representation of the set operations, right? The properties of them, the intersection, the union, and the complement. How to actually represent them on a Venn diagram. Then from there, we'll be doing calculations, mathematical calculation in Venn diagram, right? So stay tuned. We'll see you in the next one. Bye for now.
Snap Arts Media. Build your brand, capture attention, drive growth.